Hello everyone, welcome back to our channel Geomatics Engineering. Here we learn and explore the things related to geomatics engineering. So this is our next video in module land surveying. Here we are going to see how we can calculate angle with help of forebearing and back bearing, which we have learned in our previous video. So let us start. So first we should know that what is included angle. We are going to measure included angle and deflection angle with help of this. So what is included angle? So included angle is nothing. I am taking this example. This is our open traverse A, B, C, D, and this is our another closed traverse P, Q, R, S. So for example, I have done surveying. I have moved from A to B, then B to C, and then C to D. And in this case, P to Q, Q to R, R to S, and S to P. So included angle states that angle between two lines moving from previous to next line in clockwise direction. Means if you are moved from previous line to next line in clockwise direction, then your angle will be included angle, not interior, included angle. It can be it can be interior angle, or it can be exterior angle. Let's see in this closed traverse. If I am saying that I have moved in this direction, then our interior angle, we have to calculate peak angle PQR, included angle. Then our included angle will be from PQ to R, from PQ to R, previous line to next line. Then I am moving like this, previous in clockwise direction, moving like this. So I am getting this angle, and this angle is what? This angle is our exterior angle. Exterior angle. If for example if I have said that no, we have been moved in opposite direction, we have been moved in opposite direction. Let's see in this figure. This figure is for something else, but let's see in this. We have been moved in this way. Here PQ, so we have moved in this way, P to S, S to R. Then what will be our included angle? Then our included angle will be from previous line, that is P, and then from next S. So our included angle will be this. So in this case it is interior. From previous line to next line. So hope you understand the included angle. Now we will see. Just remember that we measure from previous line to next line in clockwise direction. Just remember this, you will understand what is included angle. Clockwise direction. It can be interior angle, it can be interior angle or exterior angle. It can be anything. Okay, now let's see how we will calculate this with help of forebearing and back bearing. So for example, I am taking one example from here and one example from here, then I will conclude this topic. This one is A, B, C, D. So you have taken forebearing of A. This one is the forebearing of A. I am representing it alpha 1. Also you have taken back bearing of AB, forebearing of AB, and then back bearing of AB. Beta 1. Okay. Now we are taking forebearing of next line, that is BC. Forebearing of next line, that is BC. So this one will be like this, from here to this. You know now how to measure forebearing or back bearing. If nothing given, just use whole circle bearing system, it is very good, and do calculation in this way, that from north, this one is our north, this one is our south, north, south, north, south. From north you have to move clockwise direction to the line, then you will get the bearing. So 4 bearing in the propagation of direction, 4 bearing. So 4 bearing of line, we know this alpha 2, and back bearing of same line beta 2. Okay, so we have calculated this angle. Now let's zoom it here. Okay, let's understand like this only. So we have to calculate this angle. Just understand that we have to calculate this much angle as our included end, because our propagation is from A to B and B to C. So previous line to next line in clockwise line. So we have to calculate this much angle. So let's see what we have. We have this alpha 2, this one. If we will get this angle, if you can see here, if we will get this angle, this one, this angle, then can you say that we can calculate this one. So for example, I am writing down this angle is A. So I can I say included angle here, included angle ABC is equal to A plus alpha 2, and A is what? A is nothing but, if you can see, 360 degree minus beta 1. This much is beta 1, and this one is a complete 360 degree. So A is nothing but 360 degree minus beta 1 plus alpha 2. So in this way you can calculate included angle. Same for this line. For example, let's see, I am considering this direction. Let's say I am considering this direction of propagation, and I have given some of the angles. For example, 4 bearing of PS alpha 1, 4 bearing of PS, back bearing of PS beta 1, 4 bearing of SR alpha 2, and back bearing of SR. Beta 2. So we have given this much angles. So we have to calculate which angle? We have to calculate from previous to next line in direction of propagation. So we have to calculate this angle. So can I write here included angle PSR will be equal to this alpha 2, and I am saying this B plus alpha 2. Can we calculate B? B is nothing but 360 degree minus this much beta 1. So 360 degree minus beta 1 plus alpha 2. So in this way we can calculate any type of angles, either exterior or interior, with help of 4 bearing. So now moving to our next part, that is deflection angle. So let understand this. Deflection angle is nothing but, for example, it is our problem. We have done surveying A to B, then B to C, and then D in this direction of propagation. So deflection is angle what? That how much this line BC is deflected from AC. So to measure this, we extend this line, and then we just measure this angle, and this is our deflection. So deflection angle shows how much this next line is deflected from previous line. For example, from B to C and then C to D, extend this line. This much is your deflection angle. This much is your deflection angle. So now moving further, how we will calculate this? Again, make the meridians north, south, north, south, north, south, so on. We will calculate in this only. For example, this is our A, B, C, D. So we know the fore bearing of AB, alpha 1, back bearing of AB, beta 1, fore bearing of BC, alpha 2, back bearing of CB, beta 2. We will understand in this only. So we have to calculate which angle. I am making again. We have to extend this line. For example, we have to calculate deflection angle of ABC. So we have to extend this line and we have to calculate this much angle. This much angle. So can I say that this much angle is nothing but total alpha 2 minus this much? Total alpha 2 minus this much angle. If we will do that, then we will get this del value. So then understand it, what is this value? Can you see it here? This one is parallel, this one is parallel, and this one is the intersecting line. So if you know in your 10th that alternate opposites angle are equal. Alternate opposites angle are equal. So can you see alpha 1 here, then alpha 1 here also? So then del will be alpha 2 minus alpha 1. And in this way you can calculate anywhere deflection angle. So this is about deflection angle. So in this way you can calculate horizontal angle with help of compass survey. Now moving to some extra part of this video, that is removal of errors in angular measurement. We have already seen that local attraction in our previous video, that what is local attraction and what happens due to that. So let's see how we can remove errors due to local attraction. So for that I am taking help of an example, that is you have given a closed traverse A, B, B, C, C, D, D, A, and the values of fore bearing, back bearings are given here. Fore bearing and back bearing values are given. So we have to check whether this closed bearing given to us is right or wrong. We have to check that, and then after that, if it is wrong, then what will be the right values? So for checking, we have to calculate first difference of the bearings. So let's calculate it out. 32 degree 30 minute, and here 214 degree 30 minutes. So if do it in rough, I am doing it for one only. 214 degree 30 minute is greater, so difference will be 32 degree 30 minute, 30 minute 30 minute cancel out each others, and it will come out up to 182 degree. 182 degree. So I am writing out 182 degree. Next one, if you will do this, 178 degree 45 minutes. 180 degree, and next one is our 180 degree 45 minutes. So do it by yourself and then write down. Pause the video and do it by yourself. So once we have calculated the difference, so do a thing, write down the steps. The first step is create the table of your bearings, fore bearing and back bearing, and then calculate out the differences. So your first step is done. Once you have completed your first step, that is difference of fore bearing and back bearings is calculated out. Now check whether are the readings are right or wrong. So you can see that this one is not 180 degree, this one is not 180 degree, this one is not 180 degree. Now this A, B, B, C and D, A, these three lines are wrongly measured. So we can also see that here one line CD whose difference of bearing comes to be 180 degree exact. So we will consider this line as our reference line CD and this bearing as our reference bearing. And we will consider that CD line, that is for example here CD line is free from, just understand that, free from local attraction, that there is no local attraction in CD line. There is no local attraction in measuring CD line. So we have measured CD line, and in CD line there are two stations, one is at C and one time at D. So we will also consider that these stations are also free from local attraction. So now see one thing, from one station, for example one AB, from one station we take two reading, that is fore bearing of some line and then another one is back bearing of some line. So from one station we are taking two reading, and here we have considered that this CD line is free from local attraction, that is reference line. Our reference line is CD reference line. And also if CD is free from local attraction, then our two station which lies in CD also free from local attraction. And from one station we have selected two reading. We have collected two reading. From one station we have collected two reading. One station, two readings. And here two stations are correct. That means our four readings are correct. So keep in that mind that our four readings are correct. And what are those readings? All two readings from C station and both two readings from D station. Let's see. If you are at C, then what you can measure? One you will measure is back bearing of line BC. So back bearing of line BC, that is this value. Again next value, fore bearing of line CD. Okay, this value. Again, what is the next value? If you are sitting at D station, then you will get one value, that is back bearing of line CD. That is 1 degree. And fore bearing of line DA. Means these four values are correct. Again understand what we have done from step 1. We have calculated out the difference, then the line which are having 180-degree difference, we have taken it as a reference line, and two stations at that line are also considered as reference station, and considered that these stations are free from local attraction. So if these stations are free from local attraction, each stations give two readings, so our four readings are correct. Means these four readings are our free from local attraction. So okay. So we have seen that our station, that is our station C and D, are reference station. Means all the readings taken from C and D are correct, and line CD is our reference line. So these are the four readings which we have marked that it is correct. This one, back bearing of BC, fore bearing of CD, back bearing of CD, and back bearing of D. So we will take one reading and start from there. Let's first, I am taking back bearing of BC. So I am taking that back bearing of BC. I am making again a rough figure. Back bearing of BC is correct. Okay. Let's make the north arrow. It is a rough diagram. So let's see. A, B, C. Back bearing of BC is correct. Means this reading is correct. From C, this reading is correct. That is 303 degree 15 minutes. So using the concept that for difference between back bearing and fore bearing is 180 degree, I am calculating out the fore bearing of BC. 4 bearing of BC using the corrected back bearing of line BC, that is 303 degree. Why it is corrected? Because it is measured from reference station, that is C. Why it is corrected? This because this is measured from reference station, that is C. So this reading is our corrected reading. So using this reading, I will calculate the back 4 bearing of BC. This one. Using this reading, I will calculate the 4 bearing of BC by subtracting 180 degree from it. So I am getting one. If you will subtract the value 180 degree, we will get 123. Let me check. 123 degree 15 minutes. We will get 123 degree 15 minutes. So this is our corrected 4 bearing of line BC. So we have also 4 bearing of line BC measured. This is corrected. Also we have measured, that is 124. What we have? 124 degree 30 minutes. So with help of these two reading, measured and actual, we will get the error at station B. Error at station B. What will be the error? Error is measured minus actual. So here measured is 124 degree 30 minutes. Actual is 123 degree minus 15 minutes. So error will come out 1 degree in positive, 1 degree 15 minutes. So if at station B error is 1 degree 15 minutes, it represents that if we will measure any angle with help of this station, we will get this amount of error in that station. So how much correction we need to provide? How much correction we need to provide at station B reading? Will be minus 1 degree 15 minutes. Okay, so we have already calculated one corrected reading from station B, that is 4 bearing of BC. Another reading which will be taken from line from station B is that back bearing of line AB. Back bearing of line AB. So we know that we have back bearing of line AB. What is that? Back bearing of line AB, that is 214 degree 30 minutes. It is measured from where? It is measured from station B. Station B is having how much error? 1 degree 15 minutes, means this is also having this amount of error. So correcting back bearing of line AB. What will be that? Just provide the correction. What is the correction? Minus 1 degree 15 minutes. Minus 1 degree 15 minutes. So we will get the corrected back bearing of line AB. We will get the corrected back bearing reading of line AB, that is 213 degree 15 minutes. Now I will use this back bearing to calculate the 4 bearing of line AB. Now I will use this back bearing, corrected back bearing. I am just underlining the corrected portions where I have calculated out the corrected readings. Here correction is how corrected reading, how we get? By subtracting 180 degree from back bearing. Here we have calculated corrected reading how? We have calculated corrected reading by eliminating the error at station B, because both the readings AB and that is 4 bearing of BC is calculated from where? Station B. So by eliminating same amount of error from station B readings, all the readings from station B, we will get corrected back bearing of line AB. So now I will use this corrected back bearing to calculate it. 4 bearing corrected of line AB, which will come out to be 213 degree 15 minutes minus 180 degree. 213 degree 15 minutes minus 180 degree. Then it will come out around 33 degree 15 minutes. 33 degree 15 minutes. This is also correct. This is also correct. How this is calculated? Just fore bearing minus back bearing means difference of fore bearing and back bearing. So now I got the fore bearing of line AB, and fore bearing of line AB was calculated from which station? From station A. Means if we are sitting at station A and calculating the things, then we will calculate the fore bearing of line AB. Means our this reading is calculated from station A. I am again saying station A, station B, so that you can understand that our corrected value from station A is this. But what we have measured from station A, that is 32 degree. So I am writing it down. Measured fore bearing of line AB. What is that? 32 degree 15 minutes. That means we are having some amount of error at station A, due to which we are not getting the same difference. So we will calculate again. What will be the error at station A. So again, measured minus actual. What is the measured? 32 degree 15 minutes minus what is the calculated value? 33 degree 15 minutes. There was 32 degree 15 minutes. Wait a minute. 32 degree 30 minutes. It is given 32 degree 30 minutes. It is given 32 degree 30 minutes. 32 degree 30 minutes. It's my mistake, sorry. It is given 32 degree 30 minutes. Okay. So what will be our next error? Next error will be minus 45 minutes. Minus 45 minutes means this much amount of error will be at all reading taken from the station A. So next we got error at station A. Then we will got, that is minus 45 minutes. Then we will got correction provided to station A. Correction at station A will be just plus of 45 minutes. Then one reading is corrected, that is fore bearing. So next reading from A will be the next reading taken from the station A. I am making a rough diagram. Will be the back bearing of line DA. Back bearing of line DA. This is D and this is A. Back bearing of line DA will be the next reading taken from the station A. So this reading also have same amount of error. So I am writing down back bearing measured of line DA. What is the value? 108 degree 45 minutes. 108 degree 45 minutes. So corrected will be same amount of correction we will provide in this also. Line 108 degree 45 minutes plus 45 minutes. So we will get 109 degree 30 minutes. So we got all the readings corrected here. We got back bearing of line DA. Again let's check fore bearing of line AB, back bearing of line AB, back bearing of line BC. So we got all the readings here. So again I am making a table. For the comparison. So these all are our corrected readings. We have calculated. and these all our corrected reading given to us. So using these readings, now we will again calculate the difference between these readings. Let's see, 213 degree 15 minutes, 180 degree, 303 degree 15 minutes, 180 degree. You can calculate it, just difference, take the difference out of them. 289 degree 30 minutes and 109 degree 30 minutes, 180 degree. So we can see that forebearing and backbearing of all the lines comes to be 180 degree. That means now our measurement is free from local attraction. So next our topic is removal of error due to local attraction along with removal of error due to observation, but we will do this in our separate video because our video is getting lengthy. Also, I want you all to just understand the concept behind how we are removing the error, because it is very important. It comes in the exams, and also try to understand how I have done it. I am again recalling it. Just from the readings we have taken out the differences. The difference which is exactly equal to 180 degrees is taken as the line taken as the reference line, and the stations are taken as the reference station. And we have considered that all the readings from these two stations are free from local attraction. So again, with help of these readings, we have marked the corrected readings, and with help of the corrected readings, for example, back bearing of BC is correct, forward bearing of BC is calculated out using back bearing of BC. Back bearing of BC is corrected. So then using forward bearing of BC, we have calculated how much error at station is available. Then correction at station should be applied. And then using that station's correction, we have corrected the next reading calculated from the B station, that is back bearing of line AB. Once back bearing of line AB is corrected, then with help of back bearing of line AB, forward bearing of line AB is calculated with help of that statement, that is forward bearing minus back bearing is equal to 180 degree. Again, with help of that, forward bearing of line AB is calculated, and then error at station A is measured, that is minus 45 degree. And this error is also applied to the next reading which will be taken from the station A. Then from that error and correction, line DA is corrected with help of correction plus 45 minute, and then 109 degree 30 minute is calculated out. And using this we have calculated the corrected the all readings, and that come out to be, and all the differences come out to be 180 degree. So in this way we have done it. So here I have written down the all steps taken to calculate the correct forward bearing and back bearing. So this is first calculate the forward bearing, back bearing, then calculate the differences, and then the line which having 180 degree difference, consider it reference line. Both the station of this line will be taken free from local attraction. All the readings from this station will be taken correct, and then with help of these readings other readings are calculated, and errors at and correction at different stations are calculated. And then last step is this step is repeated. This step, that is 4 and 5, is repeated until all value get corrected. Until all value get corrected. So in this way you can do this and remove error due to local attraction. So thank you. If you have any doubt, just let us know, and also share our channel. We are doing hard work to get this course completed before November and December, and also we are working on several things which will come in Telegram group, so just join there also. You will get surprises there also. So thank you and have a nice day.